All right. So for our third video here on this section, and I'm trying to keep them short in case you guys don't notice. They might seem a little long, but try to get through it, same as if you were in a classroom. And I know it's not all that much fun a lot of times, but trying to give you what you need now. And again, you can always get help by going to the Math Lab or clicking on the link. So I'm still talking about 1.1 here. And if we go back, that's the first page. If you go to the second page, talked about the definition of a function, and now they're going to formally introduce something called function notation. So in the function notation, they're going to make it look like this. Notice it's really, well, I just wrote over it, but y equals f of x. They're one and the same. It's just a condensed way to write more complicated things later. So function notation is really read as f of x or y is a function of x. You could, again, read the notation definition if you'd like, but probably more useful just to get going and take a look at it in motion. So in example 2 there, they're saying use a function notation, and again, I'm right here. Function notation to represent a function whose input is the name of a month and the output is the number of days in that month. So for instance, I don't know, what's the first month of the year? January. So there's my function, and the input right here has to go, I always say, inside the parentheses. The input is always the independent variable. It doesn't always have to be x, but independent variable, it goes inside the parentheses, and it all starts with in. Inside input independent variable. Input starts with the in. So independent put independent inside the parentheses. Anything going inside is the input. So hopefully I drilled that down. And if my input is the name of a month, so let's call it January. For time's sake, I'll just abbreviate it. So if I plugged in January, that goes in. The output, they want to be the number of days in that month. So I think there's 31 days. That's how function notation reads. And again, it's very concise. Mathematicians always like to write things very, with as quickly as possible with, very concisely. So that's how you would write that case. So the input would be January and the output would be 31 days. If you to do it with, I don't know, example 3, this is your actual machine. That's like your Coke machine. So f of x, this just means y. You're typically, back in Algebra 2 days, maybe Algebra 1, seen it written like that before, but we're not going to do that anymore. We're going to use f of x, like here. So if they're going to ask you to evaluate 3 different things, we're not always going to do every example here. Sometimes I'll leave it to you to solve some things. But if I said, hey, evaluate f of x at 2. All that is notations for plug in 2. So if I plug in 2, in other words, everywhere x got replaced with an input, all these x's have to be replaced with the 2 as well. So you might already know this, but if you've forgotten, it's good review. You've probably seen the definition of a function too. Hard to write on this screen. If you do that, 2 squared is just what? 4? 6 minus 4. 4 minus 4 is 0, so that whole thing's going to be 6. And if I were to ask you what the input is, you should tell me 2. And the output, if I were to replace it with the letter, the rules don't change, not one bit. So in the future, when I ask you, hey, if the input is A, give me the output. If I replace A, again, everywhere here, wherever you see an input of X, you would have, A squared. And this whole thing would be your answer for the output. So notice it differs at times, whereas the first question, the output was an actual answer. The second question, when I just plugged A in, my output was some version with the variable in between, and that's okay. Sometimes your output is just another function. So, and this is important when we start combining things in the future, and they're called well, nestled functions, or combinations of functions. If I were to do part C, it doesn't matter if I have a big old thing in there. F of A plus H, again, it has to go in to wherever this X is, right? Instead of A, I'm just hurting for room here, erase this. My A plus H would need to go in there and in here in its entirety. So what you would end up having, and I'm running out of room, but this whole thing, F of A plus H would equal, if I write the right side down here, A plus H, the quantity squared, 3 times A plus H. At that point, some of your instructors might ask you to go ahead and simplify, which means because A plus H is squared, you'd have 2 of these. And then you could push this 3 times A plus 3. But at this point, excuse me, I'm not asking you to do that. Just get used to plugging stuff in and looking at, you'd either have this as an output, this whole thing, or what I simplified it to, and I'm still not really done there. But right now, just please try to get the gist of it. So I have a challenge for you. Right now, if we were in class, I'd ask you to go ahead and try to figure out this version, but things are going to get reversed. Take a look at that, and right now tell me, if I tell you P is the input, is 3 here an input or an output? Looking at it, anything inside the parentheses, this is the input, right? Starts with IN, which means this is the output. Now, when that's the case, well, however it's being presented to you, and a lot of time you hear me say your instructor or they, meaning the math people in the math world outside of this class, or even myself. If I tell you that the output's 3, what I'm really asking you for, I'm going to ask you for the input then. So you can either be given one or the other. If I give you the input, I'll ask you for the output. And in this case, I'm giving you the output. Say, hey, the output is 3, figure out the input. So if the output is 3, that's code for, hey, you know that 3 is this h of p, so it can replace this value. So your function becomes 3 equals, and in that case, if I want the input, again, from Algebra 2, I'm relying on some previous knowledge. If I move the 3 over, minus 3 to both sides, some of you guys like to see that, but I end up with p squared minus 2p minus 3. And the only way to solve for that is to factor it. End up, I think, with p minus 3 and p plus 1. Now, for those of you that don't remember, there's what's called the zero product rule. So if 0 equals some quantity a times b, that thing to equal 0, either a has to be 0, so 0 times whatever, it doesn't matter what's here, equals 0, or b has to equal 0, 0 times a, whatever a is would equal 0. So that zero product rule I can use here and say, hey, either this quantity or that quantity there has to equal 0. So what you see me write a lot of times, here 0 equals p minus 3. Again, I'm running out. If I move the 3 over, plus 3. So in this case, there's 2 answers or 2 inputs that will give me, remember, I was solving for the inputs, give me this answer of 3 for an output. So very important to keep those things straight. Video's running a little long, but I guess we'll just keep on. If I scroll down, this is an alternate way to be asked the same questions. So, and that's the big word for it is we're going to be asking you to do it different ways or by using multiple representations. So either graphically, which is what this is in this example 5, or in just actual function notation, which is what we were talking about up here, or in tabular mode. There's all these different versions where the question is going to be the same every time. So don't worry about how it's being given to you. Just always think in your mind, if I'm giving you the input, figure out the output. If I give you the output, figure out the input. And over here, if your input is 2, notice it's inside the parentheses. If you're being given the input, hopefully in your mind you're saying, oh, what's the output? So if you come over to the graph when x is 2, and this is usually always the input, independent axis, and this is always the output. In this case, input's going to be x, output's going to be y. And if I'm looking at this graph, when the x is 2, my y value is right here. Actually, I think at what, 1? So my answer to this, if I plug in 2, my answer should. It's okay to put the solution there, or you can put it. So for part B, though, here's a quiz question for you. What am I asking for? Don't tell me the answer. But if I said f of x equals 4, what am I looking for? What are you being asked for? Always, if you're given something like that, you're being given what? You're being given that this quantity here is 4. Now that's outside these parentheses. It's the output. So this is the output, the y. So on your graph, if I erase my previous, on your graph, you can find that the y value of 4 is 4 here. So for an answer when y is 4, my input's 3. So for a solution, for part B, you can say that would be correct. However, be careful. Star, star, star. Do it in another question, another color. Careful when you're looking at these things because sometimes for that output, just like two different people can have the same birthday, you could get 4 a variety of ways. And in this case, if you're looking at your graph, 4 is also possible over there in the graph. If you look down at -1, that's also an answer. If I say, hey, I plug in -1, my answer is also 4. And the solution to this question for part B is both of the answers. If you only answer one, it's not correct. So make sure that you got that down. Sometimes you might have a couple answers depending on how the question is phrased. So if I were to summarize example 5 there, for an input of 2, the output of was 1. That was over here, part A. And for part B, there are 2 different inputs that yield an output of 4. So I have an output there and an output there. However, I still pass, if you remember that vertical line test, that parabola there is a function because for every input, there's only one output. You know what? On second thought here, I'll make another video in a second. Let me upload this one and come back for a short video for the rest of the notes.